This is how it all started. I became interested in viral infections when I worked in the pathology lab at Children's Medical Center of Dallas. Exhausted parents would come in bringing their children, usually under the age of 3, with chronic, unrelenting cold infections to have their lung cell biopsied for function. Now, these biopsies happened so frequently that I often got to know these families, and they were the same families that came back for the asthma clinic, and I began to wonder, was this a coincidence? Interestingly, epidemiology studies have shown us that of the 25 million people currently living in the US with asthma, more than 2/3 of them report having chronic, recurring cold infections when they were babies. Did we miss something as scientists? Could chronic colds cause asthma? Now, asthma is a disease that we've known about for quite some time now, and we've researched it very much in the past 100 years. And in that time, though we haven't developed a cure or a way to prevent the development of the disease, we have identified more than 100 genes associated with asthma. And the past 20 years have been especially fruitful because we've identified the origin of the disease as those injured epithelial cells that line the lung. Those same cells that the babies at Children's were having biopsied for altered functions during recurring colds. Yet, with all that we've discovered and all of the data that we have and all of the information that we've acquired, our best and most often prescribed device is this 50-year-old inhaler that only poorly manages symptoms and does nothing to prevent the progression of the disease. This creates an incredible opportunity for us researchers of asthma. It provides an opportunity for us not only to develop new therapeutic targets, but to design new drugs that could potentially prevent asthmatic exacerbations or asthma altogether. Traditionally, asthma research has focused on altered biochemical signaling. Now, you may not know all of these terms up here, but they're not important. The only thing that you really need to know is they focus on altered ways that cells communicate with each other and how that changes during disease development. The problem with asthma is that it is incredibly heterogeneous and has proven to be far too complex for any of these fields alone to describe. My unique approach as a biophysicist combines not only altered biochemical signaling as the disease progresses, but also cellular level mechanics, or the changes in the physical behavior of cells as they interact with each other and their environment. And when we begin to combine these two approaches, a new physical picture of the disease begins to emerge. But what exactly does that look like? Every day when you breathe, those epithelial cells function together to filter more than 10,000 liters of air filled with harmful pathogens, toxins, and of course, respiratory viruses. When I take movies of those cells, you see that they're mostly static. They remain in their position that they started in. Or to borrow a concept from physics, they're in a jammed state. But when I take movies of the epithelial cells of a person with asthma, they're highly dynamic. They're migrating. They're in an unjammed state. Previously, cell migration was thought only to occur during development, wound healing, or cancer metastases. But now we provide evidence that a cell's migratory state can be clearly understood as a physical signature of what asthma and all of its heterogeneity looks like. So using these physical metrics, immobile, non-migratory, or jammed versus mobile, migratory, or unjammed, we can begin to think about testing our hypothesis. So can we push a normal cell to behave like an asthmatic cell using only the cold viruses? Of course the answer is yes, or I wouldn't be here today. But I want to show you some really cool data. So I began these experiments infecting one-time, fully developed lung layers, just like yours and mine, and I wasn't at all surprised that much like these control uninfected cells, that they didn't move. However, when I infected multiple times throughout development, the cells displayed a remarkable transition from the more stationary cells that we normally see to these more migratory cells that we see associated with asthma. The infected cells displayed similar dynamics to the asthmatic cells. We hypothesize that the migrating cells are the starting point for the airway remodeling, and all that means is the physical changes that your airways undergo to become asthmatics. And what we think happens is the respiratory virus infects epithelial cells, those cells begin to migrate, and when those cells migrate, they release certain factors that cause a smooth muscle to grow, and that muscle begins to narrow the airway and ultimately ends in asthma. Therefore, controlling the signals of migration alone may be sufficient to blunt the development of the disease. Advances in the cancer metastases community has already produced drugs targeted directly at controlling signals of cell motion. And when I applied those therapeutics to my system, you can see that I can blunt viral-induced cell migration. Taken together, these data introduce an exciting new pathway for developing first-generation diagnostics and first-ever therapeutics aimed at controlling the development of asthma. Thank you.